All right, this is our 5.2 to 5.4 review for the quiz that we are going to have on Tuesday when we come back from the 4-day weekend. So the first set of questions say solve for the real solutions and check your solutions because there could be extraneous. So number 1, x minus 8 equals the square root of 4x. So there's nothing on the side of the equation with the radical, so I'm going to square both sides to get that radical gone. So we're going to square. And we need to remember that when we're squaring x minus 8, that means x minus 8 times x minus 8, and you FOIL that out, you get x squared minus 16x plus 64 equals 4x. We'll move the 4x over here. So we have x squared minus 20x plus 64 equals 0. Now we can factor. What two numbers multiply to 64 and add to 20? Well, that's x minus 16 and x minus 4 equals 0. So we get x is equal to 16 and x is equal to 4. Then we're going to plug that in and see if either of those are extraneous. So we get 16 minus 8 equals the square root of 4 times 16. That's 8 equals the square root of 64, so 8 equals 8. Check, 16's an answer. And then 4 minus 8 is equal to the square root of 4 times 4. That's negative 4 equals the square root of 16. Negative 4 does not equal positive 4, so that makes the 4 extraneous, and our only solution is x equals 16. Number 2, 2 times x plus 1 to the 3/4 power minus 16 equals 0. We'll add 16. 2 times x plus 1 to the 3/4 power equals 16. Divided by 2 because we want to get the parentheses by itself. And so that equals 8. And we're going to raise it to the reciprocal power when I have a fractional exponent, so that's 4/3. So 8 to the 4/3 power. So I get x minus x plus 1 equals, this is the cube root of 8 to the 4th. The cube root of 8 is 2. 2 to the 4th is 16. Subtract 1, and x equals 15. And we can plug that back in and see if it works. We get 2 times 15 plus 1 to the 3/4 power minus 16. Is this going to equal 0? So that's 2 times 16 to the 3/4, which is the 4th root of 16 cubed, which is 2 cubed, which is 8 times 2 minus 16 equals 0, and that checks. Let's move this stuff up out of the way. I'm going to clear it off so I can have space for the next problem. Number 3, the 4th root of 2 minus 9x squared equals 3x. So to get rid of that 4th root, we're going to raise both sides to the 4th power. We get 2 minus 9x squared equals 3 to the 4th power is 81. 81. Sorry. X to the 4th. So we're going to move the 2 and the 9x to the other side. Add the 9x squared. So we have 0 equals 81 x to the 4th plus 9x squared minus 2. We're going to factor this. 9x squared and 9x squared. 2 and 1 is the only way to get 2. So that gives me 9x squared. This gives me 18x squared. I need it to be a positive 9, so the 18 should be positive. That makes it plus 2. and minus 1 for the 9x, or for the 9x squared. So now we'll solve those. 9x squared plus 2 equals 0, minus 2, 9x squared equals negative 2, divide by 9. I get x squared equals negative 2/9, which is imaginary, because I can't take the square root of a negative. So that one's not a real solution, so I'm going to leave that off. 9x squared minus 1 equals 0. Add 1. 9x squared equals 1. Divide by 9. X squared equals 1/9. Take the square root plus or minus the square root of both sides. X equals plus or minus 1/3. So we're going to plug that in and see what we get. We have the square root of 4th root of 2 minus 9 times 1/3 squared equals 3 times 1/3. And that's the 4th root of 2 minus, that's 9 times 1/9. So that's 2 minus 1. The 4th root of 1 equals 1. 1 equals 1. That checks. So the positive 1/3 works. But when I put in the negative 1/3, although I get the same thing under the radical, because negative 1/3 squared is going to be positive 1/3, on the outside over here, I get 3 times negative 1/3. So that's going to equal negative 1. And this 4th root of 1 does not equal negative 1. So the only answer is x equals positive 1/3. The other ones, the negative is extraneous. Let's see. Okay, let's look at number 4 now. The square root of x minus 3 is less than or equal to 7. So when we have an even root less than, we have a domain restriction. So let's look at our domain restriction. X minus 3 has to be greater than or equal to 0. So x has to be greater than or equal to 3. Add 3 to both sides. So we're going to add that in when we're done. So then we're going to square both sides of the equation. I get x minus 3 less than or equal to 49. Add 3 to both sides. X is less than or equal to 52. And then we're going to say and it has to be greater than or equal to 3. So we write that in one sentence. 3 less than or equal to x less than or equal to 52. And that's our final answer. State the domain and range, and then graph. So for number 5, to find my domain, I'm going to take the radicand, what's underneath the radical, set it equal greater than or equal to 0, and solve this. So subtract 4. 1/2 x is greater than or equal to negative 4, times by 2, and x is greater than or equal to negative 8. So my domain is x such that x is greater than or equal to negative 8. And when I plug that in here, I get 0, and I don't have a k, so my range, and it's positive, so is y such that y is greater than or equal to 0. And then we're going to graph it. We're going to make a table. So I'm going to start with my negative 8, because that's what gives me 0. I'm going to pick even numbers so that I don't get a fraction with that 1/2. My first even to try would be negative 6. When I do 1/2 times negative 6 plus 4, the square root of that, that's negative 3 plus 4 is the square root of 1, which is 1. Okay, that works out nicely for me. We'll try negative 4. The square root of 1/2 times negative 4 plus 4. That's going to give me negative 2 plus 4, the square root of 2. Well, that doesn't really help me much. Let's try 0. The square root of 1/2 times 0 plus 4. That's the square root of 4, which is 2. Okay, that was a good choice. Negative 2 would have probably given me the square root of 3. And that's pretty much enough to draw a good graph here. So, hold on, that's not a good line. I need more space to the left. This way. 1, 2, 3, 4, 5, 6, 7, 8, negative 8, 0, negative 6, 1, and 0, 2. So your graph, I missed it. Try again. It's like that. It's a really bad curve. And there you go. Let's draw number 6. Negative 2, square root of x. Hold on. Minus 1 plus 3. Okay, so we're going to first find our domain restriction by looking at x minus 1 has to be greater than or equal to 0, because your square root has to be greater than or equal to 0, and we'll add 1. So our domain is that x such that x is greater than or equal to positive 1. And it's negative, so that's a reflection. That means my range, instead of being greater than this 3, it's actually going to be less than or equal to 3. And we'll confirm that as we graph it. So let's look at our table. We're going to start with our domain restriction. So we're going to start at this number here, the 1. And when I plug that in, we get negative 2 square root of 1 minus 1 plus 3. Negative 2 square root of 0 plus 3. Negative 2 times 0 plus 3 will just give me 3. Then the next number I'm going to plug in is, let's try 2. Because if I put 2 underneath there, I get 2 minus 1, which will be a perfect square. So negative 2 times the square root of 2 minus 1 plus 3. Evaluate the square root first. So negative 2 times 1, which is negative 2 plus 3 is positive 1. And then the next one, if I plug in 3 minus 1, that gives me 2. That's not a perfect square, so we'll skip 3. 4 minus 1 is 3. That's not a perfect square, so we'll skip 4. And how about 5 minus 1? Let's try 5. Negative 2 times the square root of 5 minus 1 plus 3. Negative 2, that's the square root of 4, so that works out nicely. And that's negative 2 times 2. Plus 3, that's negative 4 plus 3, which is negative 1. And then the next one is probably going to be 10, because the square root of 10 minus 1 is 9. So negative 2 times the square root of 9, which is 3, plus 3, that's negative 6 plus 3, which is negative 3. So those are my values in my table. So notice I just plugged in all the numbers, but if it didn't give me a perfect square under the radical, I just skipped it. And we can see that our y values are starting at a positive 3 here, and they're going smaller. And that is why my range is less than 3 instead of greater than 3. So now let's draw our graph. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 1, 2, and 3. So we'll do this in blue. I have 0, positive 3. I have, I'm sorry, it's not 0. Let's undo that. It's 1, positive 3. And it's 2, positive 1. And then it's 5, negative 1. And 10, negative 3. And the graph looks like this. There we go. Connected in a curve. It does not go past this point here, right? This is a starting point. It does not continue in that direction. So it's like a ray, but curved. Next, write a rule for g described by the transformation on f of x. Number 7, a horizontal shift. Write 3 units. That's f of x minus 3, followed by a reflection in the x-axis. So then we'll do negative f of x. Okay, we like it when you write these out separately like this. Okay, so we're going to start by f of x minus 3. Remember, this means we're going to plug x minus 3 in for the x. So I have f of x, this is equal to the cube root of 2 times x minus 3 plus 5 minus 7. And then we distribute the 2, so the cube root of 2x minus 6 plus 5 minus 7, which is then the cube root of 2x minus 1 minus 7. Then I'm going to do negative f of x, which means I'm going to take this and multiply it by a negative. Remembering to distribute it, it goes in front. A lot of times students don't put it in front, they distribute it to the one on the end. It goes in front, so negative cube root of 2x minus 1, and it distributes to the negative 7, so it becomes plus 7. And that's our new function, g of x. And number 8, a vertical stretch by a factor of 2, so that's 2 times f of x, followed by a horizontal stretch by a factor of 3, that's f of 1/3 x, and then a reflection in the y-axis, which is f of negative x. So we're going to do those in that order. So we're going to start by multiplying the whole thing by 2. 2 times the square root of negative 6x plus 1 plus 4. And then remember, it becomes 2 square root of negative 6x plus 1 plus 8. We must distribute it. And then we're going to substitute the 1/3 x in for x, so negative 6 times 1/3 x plus 1 plus 8. It just multiplies the 6 and the 1/3 x, so that's 2 square root of negative 2x plus 1, because 1/3 of 6 is 2, plus 8 on the outside, and then f of negative x plugs in negative for the x, so negative 2 times negative x plus 1 plus 8, which is 2 square root of 2x plus 1 plus 8 is our g of x function. Okay, so the next set is to simplify and assume all variables are positive. This is a really important distinction here. This means we do not have to worry about absolute value. So we're not going to do absolute value on these problems. Okay, so that's what this means, and you have to know that, especially for like SATs and stuff. You want to know that you don't have to worry about putting the absolute values in there when it says assume all variables are positive. So for number 9, I have 4 times the 5th root of 2. Or sorry, 4 divided by the 5th root of 2. And I have to rationalize this denominator. And to do that, I need to multiply by 5th root of something so that I have a perfect power of 5 underneath that radical. So in a 5th root, I'm looking for groups of 5. So I want 5 total 2's. I have one already, so I'm going to multiply by 4 more. And when I do that, I have the 5th root of 2 to the 5th, which equals 2. And that rationalizes my denominator. Whatever I do to the bottom, I also have to do the top. And there should be those in there. It's not showing up. And so I have 4 times the 5th root of 16. They said this is our denominator, 2 over 2. 2 goes into 4 twice, so we get 2 fifth root of 16. And that 5 should be under that little radical. So 2 fifth root of 16 is our answer. And number 10, black. I have the fourth root of 3y over the fourth root of 8x squared. So I recognize 8 as a cube number, so I'm going to rewrite that fourth root of 3y as the fourth root of 2 times 2 times 2 times x. Let's just look at it like that. Now, it's not a necessary step if you see it right away, but sometimes it'll help you see it. It's the fourth root, so I need 4 of something. I have 3 2's already, so I'm going to multiply by fourth root of 2. I need 1 more 2 to make it 4 of them, and I have 2 x's, so I need 2 more x's, so 2x squared. So I have the fourth root of 2x squared multiplied on the top. When I multiply my radicals on the top together, 3y times 2x squared, I get the fourth root of 6x squared y. And in the bottom, I end up with the fourth root of 2 to the fourth, x to the fourth, which is then the fourth root of, 6x squared y over the fourth root of 2 to the fourth is 2, and the fourth root of x to the fourth is x. And this is where we don't have to worry about absolute value when we're rationalizing these expressions, because it said assume all variables are positive. So that's my answer. Let's move these things up here. Number 11. Cube root of 12x over the cube root of 48. Let's write 48 as 3 times 2, which is 6. And 6 times 8 is 48. 8 is 2 times 2 times 2. So we did 48 is 6 times 8. And then I broke the 6 down into 3 times 2, and I broke the 8 down into 2 cubed. So here, I already have 3 2's that can come out, but I only have, then I have a leftover 2 and a leftover 3. So when I multiply, I'm going to move this answer out of the way here. And then we have x squared also underneath there. So I need to multiply so that I have groups of 3. I already have one group of 3, but I have 1, 2, so 2 squared will give me 3 more, 3 total, and a 3 squared will give me 3 total 3's, and then I need 1 more x to make it x cubed. So I'll multiply by the same thing on the top, 2 squared times 3 squared times x. In the top, I'm going to break 12 down to 4 times 3, which is 2 times 2 times 3. There's my 12. And then I have 2 times 2 for this 2 squared, 3 times 3 for this 3 squared, and x, because I have this x and this x. I know that looks like a lot. And in my denominator, I'm going to consolidate a little bit. I get 3 cubed, 2 to the 6th, x cubed. So my denominator is going to simplify a little bit easier than my numerator, and that's always the case because we want it to come out even. So I get 3 times 2x in my denominator, 2 squared x, because a cube root of 2 to the 6th is 2 squared. And then my numerator, I have groups of 3, 1, 2, 3, that's one group of 2. And then I have a leftover 2, and then I have a group of 3, and then I have the 2 x's that can't come out. So what comes out is 3 times 2, cube root of the 2 and the x squared are left over, 2x squared. So I get 6 cube root of 2x squared over 12x. 6 goes into 12 twice. So you have the cube root of 2x squared over 2x. That's my answer. All right, we're going to make some space again. All right, let's look at number 12. 5 minus the square root of 6, and I'm going to do my vertical multiplication here, 2 plus 3 radical 6. So we're going to multiply 3 radical 6 times negative radical 6, which is going to be negative 3. Radical 6 times radical 6 is radical 36, which is 6. So 3 times 6, which is negative 18. And then 5 times 3 radical 6 is 15 radical 6. 2 times negative radical 6 is negative 2 radical 6, and 5 times 2 is 10. So put that underneath there. So I have 13 radical 6. This is 18, negative 18 plus 10 minus 8. And we usually write the number first, negative 8 plus 13 radical 6. Number 13, radical 2 over 4 minus radical 3. We multiply by the conjugate, which is 4 plus radical 3. 4 plus radical 3. Distribute on the top, 4 radical 2 plus radical 6. Radical 2 times radical 3 is radical 6. Multiply out the bottom, 4 times 4 is 16. 4 times radical 3 plus 4 radical 3. Negative radical 3 times 4 minus 4 radical 3. So these cancel, and negative radical 3 times radical 3 is negative 3. So we have 4 radical 2 plus 6 plus radical 6 over 13. Okay, so now we're at number 14. Let's see if we can move this stuff out of the way. So we want to simplify each of our radicals. We have the cube root of 16, so that's negative 2 cube root of 2 times 2 times 2 times 2. So there's a group of 3 in here. So that becomes negative 2 times 2 cube root of 2, which is negative 4 cube root of 2, plus the 5 cube root of 2, that's already simplified. And 54 is 9 times 6. 9 is 3 times 3. 6 is 3 times 2. So that's negative 5 cube root of that. And we have our 3 3's underneath the cube root. So I can take that out, and that's negative 5 times 3 cube root of 2, which is negative 15 cube root of 2. Now we're just adding up how many cube root 2's we have. We have negative 4 plus 5 minus 15. Negative 4 plus 5 is 1. 1 minus 15 is negative 14. And I have cube root 2's. That's what I'm adding up. And that's my final answer. Next, we're simplifying these expressions still with we're assuming all variables are positive, so we're not going to worry about absolute values. I have 7x to the 1/4 minus 10x to the 1/4. So again, this is just combining like terms. 7 minus 10 is negative 3, and what am I combining? X to the 1/4 power. So negative 3x to the 1/4 power. And remember, the general rule is if it starts as a fractional exponent, we can leave it. We don't need to convert it to a radical. Number 6 is 6 times the 5th root of 18 times negative 2 times the 5th root of 81. And so that's 6 times negative 2. We multiply those, so I get negative 12. Then we multiply 18 times 81. 5th root of, and I'm not actually going to multiply that out. I'm going to leave it as 2 times 9. And 81 is 9 times 9. And then I'm going to make that 2 times 3 times 3 times 3 times 3 times 3, and times 3. That's 9, 9, and 9, 3 9s. And I'm looking for 5 of them, so 1, 2, 3, 4, and 5. So those 5 are going to come out. So negative 12 times the 3, fifth root of what's left is 2 times 3, 6. And I can shorten that up. Now I can multiply what's in front. Negative 36 times 5 radical 6. And then number 17, this is the last one in this set of problems. We have 3 minus 3 radical 2 minus radical 2. We have plus 4 cube root of 6 plus 7 square root of 2 minus 8 cube root of 6. So this is like terms here. I'm going to highlight in yellow my square root of 2, square root of 2, square root of 2, and I'm going to highlight in green my cube root of 6's. So those are the ones I'm going to add up. I have 3 minus 1. Remember, there's a 1 in front if it's not written. So 3 minus 1 plus 7 is 2 plus 7, 9 square root of 2. And 4 cube root 6 minus 8 cube root 6 is negative 4 cube root of 6. Okay, 18 through 23 are used the rules of exponents to simplify. Rules of exponents are if you're multiplying powers, we add. For dividing powers, we subtract. Power to a power, we multiply. And negative exponents, there should be no negative exponents in your answer. So we have 5 to the 9 11ths. So we have 9 11ths plus 7 11ths. The denominators are the same, so we're going to add 9 plus 11 is 26. So that's 5 to the 26 11ths over 5 to the 4 11ths. And that's 5 to the 22 11ths when I subtract my exponents. And you should be reducing the fraction when it can be. So that's 5 squared, which is 25. Number 19, this is 7 to the 1 over 7 to the 2 ninths. So 1 minus 2 ninths, that I can make 9 ninths. 9 ninths equals 1 minus 2 ninths, and that is 7 ninths. So 7 to the 7 ninths. My denominator stays the same. We don't divide out the denominators. So that's 19, 20. We can divide 2, goes into 8 4 times, so we're going to leave the 4 in the bottom. I like to simplify the radical or the fraction inside and then apply the exponent on the outside. It's just my personal preference. A to the negative 3 minus negative 6. So it's negative 3 minus negative 6. Pay really close attention when you have lots of negatives. So this becomes negative 3 plus 6. So the a to the positive third power, that goes in the numerator. And then we have b to the fourth over b to the eighth. That's 4 minus 8, which would be negative 4. So that's b to the negative 4. Negative exponents go on the bottom, so b to the fourth. And then we're going to raise that to the third power. So we get, all the way over here, a through a cubed is a to the ninth. 4 cubed is 64. And b to the fourth cubed is b to the 12th. I'm sorry, that was number 21. So let me do number 20 now. That's 21. Number 20, 3x cubed y to the negative 4 to the negative 2 power. So that's 3 to the negative 2 power, which is 1/9. Then I have x cubed to the negative 2, multiply 3 times negative 2, that's x to the negative 6, which means x to the positive 6 goes in the denominator. And then y to the negative 4 to the negative 2 power becomes y to the positive 8, so y to the 8th in the numerator. And I could put the 1 there or not. So y to the 8th over 9x to the 6th. And All right, number 22. Oops. 4x to the 5th, y to the 7th over 6x, y to the negative 2, 8x to the negative 3, y to the negative 5, 12x to the 5th, y squared. So again, my preference is I'm going to do the top. I'm going to do the top, combine that together, and then I'll do the bottom, and then I'll do the division in the end. So, well, let's multiply the numbers first. 4 times 8, 32. 6 times 12, 72. X to the 5th times x to the negative 3. Add my exponents, 5 minus 3, x squared. Y to the 7th, y to the negative 5. 7 minus 5, y squared. Then I have x and x to the 5th. So x to the 1st, x to the 5th. That's 1 plus 5x to the 6th. And then I have y to the negative 2, y to the 2, that's 0. So now I can reduce my fraction by 8. 32 divided by 8 is 4. 22 divided by 8 is 9. And we have 4 more in the denominator. So 4y squared, when I do 2 minus 6, I get x to the negative 4. And that makes x to the 4 in the denominator. Oh, and I forgot the 9. Put my 9 in there. And number 23. 9 to the 3/8 times 27 to the 1/4 over 3 to the 1/8. Well, my bases aren't the same, and neither are my exponents. So what I have to do is make my bases all the same. These are all powers of 3. So 9 is 3 squared. So I get 3 squared to the 3/8. 27 is 3 cubed. So 3 cubed to the 1/4 over 3 to the 1/8. And 2 times 3/8 is 6/8. So we have 3 to the 6/8 times 3 to the 3/4 over 3 to the 1/8. I need to make this a common denominator, so I'm going to multiply by 2. So I get 3 to the 6/8 times 3 to the 6/8. Sorry, it's getting messy. Times 3 to the 1/8 over 3 to the 1/8. Add 14/8 minus 1/8. So subtracting the bottom. And that gives me, geez, I need some space. That's 3 to the 14/8. I'm sorry, where did I learn to add? 3 to the 12/8 over 3 to the 1/8 gives me 3 to the 11/8. Okay, so let's fix that in right here. Okay, so this set is where I'm going to worry about the absolute values. Remember, it's even index, even exponent underneath gives me an odd answer. It needs my absolute value. Okay, so number 24 is a cube root. Don't have to worry about it. Cube root of 64 is negative 4. So the cube root of negative 64 is negative 4. Then we have a to the 26th. So we're saying how many groups of 3 are in 26? So that's really dividing 26 by 3. That's 8. So I get a to the 8. 8 times 3 is 24. That leaves 2 a's remaining. So a squared goes on the inside. The cube root of b cubed is just b. And the cube root of, let's see, c to the 6th is c squared. So I need to make some space here. C squared, cube root of a squared. Negative 4, a to the 8th, b, c squared, cube root of a squared. Number 24, this is an even, so I have to worry about the absolute values on this. If it's even, and it comes out off. Number 25, the fourth root of 81 is 3. The fourth root of x to the 12th, 12 divided by 4 is 3, that's x cubed. So that's even, it came out odd, so I need absolute value around that x cubed. And fourth root of y to the 8th is y squared. We don't need it on the even. 26. The sixth root of 64 is 2. The sixth root of 8 to the 6th is a. It was even, came out odd, needs the absolute value. Sixth root of b to the 18th is b cubed, also needs the absolute value. So we'll put the absolute value bars around both the a, b cubed. We get to absolute value of ab cubed. All right, we're looking at 27. Fifth root of 96x to the 15th, y squared. So 96 is 8 times 12. 8 is 2 times 2 times 2. 12 is 4 and 3. That's 2 times 2 times 3. So here's a 5 2's, so I can bring a 2 out. And then I'm going to have the fifth root of 3. The 3 is going to stay in. Then the fifth root of x to the 15th. 15 divided by 5 is 3, so that's x cubed outside. And 2 is less than 5, so the y squared has to stay inside. So it becomes 2x cubed, fifth root of 3y squared. Okay, 28. Fourth root of negative 216. A to fourth, b to the 8th. Well, fourth root of a negative has no real roots, because no matter what, we're not going to be able to have the solution here. So there's no real solutions. And especially because these are even. So even if I put negatives in for my variables, it's still going to be negative under that radical. Number 29, the square root of negative 3 to the 10th. Remember, the square root has a 2, imaginary 2 there, so we're dividing 10 by 2. That becomes negative 3 to the 5th. It was even, ended up odd, so I need the absolute value. Negative 3 to the 5th is 243, negative 243, and the absolute value of that is positive 243. And I believe this is the last problem. Describe the transformation on the function square root of n plus 3 plus 6, which resulted in the function g of n equals the square root of 1/4 n plus 3 plus 8. So we're going to look first for vertical or horizontal shifts. Then the 3 is the same, so we have this no horizontal shifts. Then we'll look for shrinks and stretches. Here is a horizontal shrink, because the factor, I didn't spell that right. Factor is the reciprocal 4. Okay, and then we went from a positive 6 to a positive 8. There's no negatives, so there's no reflections. So then it's a vertical translation up 2. So horizontal shrink factor of 4 and vertical translation up 2. You want to look at them in the order that we describe them as well. Horizontal translations, then your horizontal shrinks and stretches, your vertical shrinks and stretches, your reflections, and then lastly, if the vertical translation is different.